All right. Hey, everyone. Welcome to day 21 of Math 133. Today, we are going to talk about the Chapter 9 review, which starts on page 495. In your course pack, page 495. And it's 5 pages, so make sure you grab all 5 pages. Make sure you submit all 5 pages. Some of our other worksheets, chapter reviews have been 4 pages, so. All right. And page 495. So the chapter 9 is all about confidence intervals. Okay. So confidence interval is going to be a lower limit and an upper limit. It's two numbers. And it gives you a range for where you expect the population parameter to land. Okay. Um, so for example, if I am measuring like the average height of people in the US, or if I was measuring, what percent of M&Ms are red, or what percent of people are going to vote Democrat or Republican. If I'm trying to figure out any of these different things, how effective is my vaccine? How many people are going to buy my product based on seeing my commercial? All those different things. We can't measure the entire population. Okay, the population is too big. So we do a sample and we look at the mean or the proportion in that sample and we say, that's probably really close to the population. Okay. Now we know it's not exactly equal, but we say it's close enough. Okay. How close is it? Well, that is what the confidence interval tells you. It tells you, okay, here's what the sample says. You can expect the true value of the population to land somewhere in this range, somewhere in this interval. Okay. Now, it's not going to be 100% accurate because you can never be 100% accurate. In order to be 100% accurate, you need to sample the entire population. You need to measure everyone. And we've already said we can't do that. Okay. So, uh, but we can be pretty dang confident. We can be 95% or 99% confident and have a pretty good estimate for what the true value is. Okay. So that's the idea with confidence intervals today. Now, just like all of our worksheets, we're going to give you some hints and then we'll stop and we'll go back through. Let's see. In a 2020 CDC report, it was found that 52.6% of Michigan residents over 60 had been vaccinated for shingles, 1.9% margin of error, 71% confidence. Okay, what is the population? So the sample here is how many people you uh, measured, okay, how many people you checked. But the population is all, okay, all something, okay. Um, and then to compute the confidence interval, so that's on page 259. So Nathan's got it. What is the population? It's all Michigan residents over 60. Okay. Now, on page 259, when we're doing a confidence interval, we've got a couple different formulas. There's this formula here, which is, crazy complicated. We got this complicated formula down here, but it's not that complicated. What it does is, so you take your sample and you measure the middle for that. You measure the mean or the proportion for your sample, and that's going to be this dead center of your confidence interval. Okay. And then if you add the margin of error or subtract the margin of error, that'll give you your upper limit and your lower limit. Okay. So the margin of error is all of this stuff right here with the square root. Well, we don't need that here. For this one, they gave us the margin of error, 1.9%. So if that's the case, you'll just do your center, your point estimate, p hat, plus or minus your margin of error. Okay. Compute alpha. So alpha is related to your error, okay? So in other words, we're never going to be 100% confident. This case, we're 71% confident, okay? That's pretty low, but that is the area that we would shade in the middle here, okay? The white space on the left and right, that's going to be your alpha, okay? So confidence level plus alpha adds up to 100%. So if you know your alpha, you can find your confidence level. If you know your confidence level, you can find alpha, okay? All right. All right, so next one. Number two, a researcher wants to construct a 93% confidence interval for the proportion of American women that say willpower alone is not enough for most people to lose weight. Estimate how many American women need to be surveyed if no prior estimate is available and the researcher wants to be within 2.1% of the true proportion. So we need to give the formula. We need to do substitution. And we need to give the result. Okay. And the formula for this, so that's on page 261, where we're looking at how many, so what size of a sample do we need to do? And there's three of them. There's this one, and this one. These two are if you're measuring a proportion. This one is if you have a prior estimate, no prior estimate. This one is if you have if you're measuring a mean. If you're measuring a mean, okay? So this is page 261, okay? Pew Research poll in 2024 estimates this proportion to be 0.71. Using this estimate, how many American women are needed? So same thing, we want to give the formula, substitution, and a result, okay? But this time we have a prior estimate, so that's going to be this one, okay? So if you have no prior estimate, we do 0.25. With a prior estimate, we do this one, okay? Now, these are actually the same formula. They don't look the same. The difference is that this one has a 0.25. Where did this 0.25 come from, right? Why is it that not, I don't know, something else? So if we were trying to measure something, like if I was trying to measure, you know, what percent of Michigan residents are vaccinated with shingles? No idea. Is it 40%, 90%? I have no clue. Okay. So when you have no prior estimate, you have no guess, just pick a number in the middle. So right in the middle is 50%. If your p hat was 50%, that would mean your q hat is 50%. And what is 50% times 50%? Well, in your calculator, that is 0.50 times 0.50. It's 0.25. And that is where this 0.25 comes from, is if you have no prior estimate, just pick a number in the middle. Pick 50% and use that for p hat and q hat, okay? Now, if you do have a prior estimate, then you won't have to sample quite as many people because you can use a smaller p or a smaller q, okay? 50% will give you the largest sample size that you would possibly need, okay? And actually, if your p hat is 50%, if your prior estimate is 50% or close to it, then really these two formulas are going to give you the same result. So it's not really any better having that prior estimate, okay? But anyway, no, that's totally fine, Nathan. If you don't want to write out the full word, you can write FSR. I'm fine with that. I know what you're doing. On your assignments, I'm never grading your answer. I'm grading your understanding. Okay. You may have seen some cases where you actually got the answer wrong, but you actually got full credit for it. And that was because I could tell that you understood what you were doing. Okay. So if you write FSR, I know it. It's clear that you know what you're doing. All right, moving on. Let's go on to the next page. Question number 3, find the following. So you have your n, you have your p hat, we want to find x. So p hat is probability. So probability is the number of wanted results, which in this case is x. X is the number of successes divided by n, which is your sample size. So you'll need to use that to figure out your x, okay? All right, question number 4. A CDC study in 2024 found out that a random sample of 2,000 US adults over 60 years old, 1,200 of them have been vaccinated for tetanus. Find p hat, q hat. So same thing. P hat is x over n, okay? And then you can find your q, all right? Part B, verify the requirements for constructing a confidence interval for P. Give explanations with context. So for this, you need to make sure that your sample size, your sample is random. Your sample size is not too big, so independent. And your sample size your sample size is big enough, so you need to check normal. Okay. When you're checking these, it's the same steps that we talked about in chapter 8 when we were checking to make sure that our central limit theorem was satisfied. Okay. Now, independent, there's 2 ways you can do it. One is you need to make sure that your sample size is less than 5% of the population. Okay. You can do this if you have a number for your population. If you don't have a number for your population, it's easier to use this one. If you multiply both sides of this equation by 20, you get 20n is less than 20 times 5% is 1. So you get 20n is less than capital. Okay. This one's usually a little easier to deal with because we don't have decimals and also because we might not have a number over on this side. Okay. But that's where the 20 comes from. So 5% we said is unusual, right? 5% is 1 over 20. Okay. So if I'm rolling a d20, if I'm rolling a 20-sided die, I'm playing Dungeons and Dragons, a natural 20 is unusual. Okay. Hey, Lane, how's it going? So Cindy is at the airport,
Yeah,
and we all know how much time that takes these days.
that's right. She
So,
said she's delayed 2 hours.
no, yeah.
Do you
Um,
need
yep.
anything else at all?
No, we're good. So thanks for jumping on. So,
You're welcome. But
uh,
this, I love this. Good to see it twice.
nice.
I'll
All right. Well,
take it.
yeah, thanks. We're good. So, um, all right. For C, construct a 96% confidence interval for P. So we need to give the formula for that. Substitution, and our results. Okay. And this is on page 259. Okay. So the formula we're going to use depends on if I'm looking at proportions or if I'm looking at means. Okay. Interpret, the word interpret means we're going to write a sentence in English, right? Explain what that result is. Okay. And let's move on to the next page. Page 497. Zoologist wants to estimate the average weight of the male giraffes in captivity. To do so, she will construct a 90% confidence interval, margin of error 45 pounds. She knows from San Diego Zoo. Male giraffe, standard deviation of this. How many giraffes does she need? So we need the formula, substitution, and a result. And since we're measuring a sample size, how many? That's page 261. Okay. The sample size from part A, it's larger, smaller, larger, smaller. So you'll find information on page 207 and 208 about what happens if you have a larger sample size or a smaller confidence level, all of those different things. So you can take a look at that. But I like to just remember that uh, if you have a larger sample size, that means more accuracy. Okay. Now that does bring up the point that if a larger sample size is better, why don't you just always use the largest sample size you possibly can? Okay. And it's because it's expensive. Okay. Um, if I need to, in this case, I'm weighing giraffes. Um, I don't know how difficult it is to weigh a giraffe, but it doesn't sound like fun. Do you have to like tranquilize them or like, I don't even know. So like the reason why you can't just sample everyone is because it's not easy to do. So, it could be dangerous, right? I don't know how dangerous giraffes are, but um in order to give an accurate confidence interval, you need your sample size to be big enough, right? We need n to be bigger than 30 or n times q to be bigger than 10, right? Um, but the bigger your sample size, the better, but it also means it's more expensive. Like even if I was talking about like trying to measure like, I don't know, who's going to win the next election, I have to send people to, I have to do a random sample. So I have to send people to random people's houses and ask who they're going to vote for. And sometimes people will volunteer for that, uh, right? But sometimes it requires you to pay those people. And it's also going to take time. If I have to go talk to 1,000 people, if that's how big my sample size is, that's going to take time. It's going to take money. So, but I'll press again, like bigger sample size is better, but there's a reason why sometimes you can't do that. So, question number 6. According to the recent FDA study of 64 people, it was found average American consumes 142 grams of sugar. Margin of error is this. All right. Compute the confidence interval. So in this case, they gave me the margin of error. So I don't need to go do a bunch of crazy formula substitution result stuff, right? It's just your point estimate. I'm going to write that as point estimate plus your margin of error. Point estimate is p hat if you're doing probability. It's x bar if you're doing means. Okay. And then you add the margin of error and you subtract your margin of error. Compute alpha. So confidence level plus your alpha, that's 100%. Degrees of freedom. Degrees of freedom is n minus 1. And then compute your critical t values. Okay. All right. Next page. 498. During the 2021 academic year, researcher gathered the in-state tuition for a random sample of 15 public year colleges, four-year colleges in the U.S. There are 2,637 four-year colleges in the U.S. Found that the average in-state tuition was this, standard deviation. Verify the conditions are met. So we need to make sure that our sample is random, that it's independent, and normal. All right. Construct a 90% confidence interval for your mean. So we need the formula. Do some substitution and get a result. And this formula is the one on page 259. And then interpret the confidence interval with a sentence. Okay. Last page is page 499. A researcher for the Bureau of Labor Statistics created a confidence interval for the amount that U.S. households spend on transportation annually. So here's all the StatCrunch results. I give all this information. So once again, alpha plus the confidence level. If you add these together, you get 1. Degrees of freedom is n minus 1. And then the point estimate and the margin of error. So in this case, they didn't give us the point estimate. They gave us the upper limit and the lower limit. So the idea behind a margin of error, or behind a confidence interval. So we can't measure everyone in the population. So instead we do a sample and we measure the mean for the sample. That's X bar. Or if you're looking at a proportion, it's P hat. That number is going to be right in the middle of your confidence interval. Then if you add your margin of error, so plus this margin of error, that gets you to your upper limit. If you take your point estimate and you subtract your margin of error, that gives you your lower limit, okay? So why am I pointing this out? So this is 1 margin of error, 2 margins of error. So if you have your upper limit and lower limit, and you want to find your X bar, your point estimate, it's directly in between your upper and lower limit, okay? So in other words, it's the average of the two. To average those, to find your point estimate, you take your upper limit plus your lower limit and you divide by 2, and that will give you your point estimate. For margin of error, well, I have my lower limit and I have my upper limit. If I subtract those two, that will tell me the distance between them, but that is 2 margins of error. So if I do upper limit minus lower limit, that gives me double my margin of error. So if I divide that by 2, that'll tell you how far your margin of error is, okay? Now, these two formulas are not in your exam notes packet. You might want to write them down on your 8.5 by 11 piece of paper, though. They're very similar, right? It's one's a plus, one's a minus. So, all this stuff is on page 207 and 208. I think that is all the hints. All right. So let's jump back to page 490.